So we are, yes, we're going to be talking about performance. We're going to be talking about both page load performance, so getting things to load quickly, and then we're going to be talking about 60 frames a second kind of stuff as well, the runtime aspect of this. So introducing the panel then. At the far right we have Pat Meenan, software engineer on Chrome. If you've ever used something like webpagetest, you've used one of the finest performance tools that we have available today. And if you haven't, go to webpagetest.org and shove in your site and find out how you're doing. It really is that good. To his left, my right, that's Paul Irish, which I think most of us know him. Product manager on Chrome. I think we do know him from things like jQuery, Modernizer, and of course Chrome DevTools. He's sort of been involved in that for a good long time. To my right, we've got Siddharth Vijayakrishnan. He's a product manager focusing on Chrome's network stack, ensuring that Chrome loads in the best way possible, and he's also responsible for the Chrome data compression proxy on Android as well. To my left, it's Nat Duca. He's a software engineer on Chrome, and if you've heard the word jank, then essentially that's down to Nat, pretty much. He's the person behind Chrome's Trace Viewer, GPU rasterization. Basically, I discovered pretty early on in my career at Google that most graphics roads kind of lead back to him for good or ill. To his left, it's Jan. And he's a software engineer who works on things like mod PageSpeed or Nginx PageSpeed. So if you've never tried those, you absolutely should. They can make a world of difference to your site. They optimize your content automatically on the server side, so you don't have to think quite as hard about all that. And then at the far left, a late addition and a very kind and willing person to join us is Alex Russell. He's going to hopefully help us out a little bit with things about Serviceworker, because it's going to come up. Let's be honest, it's been on the tip of everybody's tongue for the last day or so. So, all right, so we'll get started. Question from a guy called Paul. I like how this starts already. Oh yeah. Paul for performance, performance for Pauls. It's good. Performance is a massive area. It's a fair question. So where should I invest my efforts? On the network or on the client and rendering pipeline? And if I can't do all of it, what do I spend the bulk of my time on? Who wants to go? Pat.
I think it's largely going to depend on what kind of app and experience you're delivering. If you're delivering sort of more of a content experience, you're probably going to want to focus more on the loading. If you're delivering sort of a rich app interactive experience, you can afford to spend more time on the loading to get all of the experience there ahead of time and have the rich interactions and really smooth interactivity with the user.
Does that sort of bank on having Serviceworker there? Are you sort of saying, well, you know what, actually we just figured that that first load will take the hit, and then we hope that things will be better for future load?
I mean, just look at how your users are going to interact with your content, right? If they're going to interact with it as an app, focus on their actual interactions. If they're going to go to it to consume content and sort of jump away, get the content to them as quickly as you can.
Okay. Nat, do you feel the same?
Oh, yeah, totally. I mean, this all begins with the model of your users and who you're trying to attract and make money from or exploit in some way, right, clearly. So if you have terrible jank, it's going to drop them right out. So there's sort of this baseline you need to achieve across the board. If you have a 10-second page load time, you're going to lose people, and you need not to do that. Once you get down into sort of the baseline of you are mostly smooth and you are mostly quickly loading, then you get into this nuance, right? So first of all, get that baseline established. And then from there, you want to decide, are people returning to your site enough to start benefiting from cacheability and things on that side? And the cool thing here is there's this trade-off of, especially if you can start assuming Serviceworker cacheability, you start being able to simplify your loading process and have a little more free time to do great, smooth UI effects, right? But you really have to do both. You have to plan to figure out how to afford to do both. And then if you can't afford to do both, you're going to have to figure out which side to simplify in order to get to the end of the your launch.
No.
Alex nodded.
I was going to add in one thing, which is, I mean, thinking about it from kind of the user perspective, the page load is like your introduction to them. And if you are just like stuttering while you're introducing yourself to someone, it's not going to really work out so well. So there's the introduction, and then there's where you actually like demonstrate your value, and that's more of like the application performing and things are smooth and not breaking user expectations. And so obviously we have to do both of these things. Comes a lot down to you seeing what your users' pain points are, and so getting good feedback from them on kind of like it feels weird, it feels slow, and then tell me more about the slow thing. Well, when I come to it every single day, and it takes so long for it to like get up and running, then you understand that it's all about kind of that initial load. So, I mean, you have to do both, and just identify, kind of work with the user to identify what is really impacting their perception of the experience.
Okay, fair enough. Sort of, I guess, related to that, if this is another question from another poll. I fully approve of all the polls asking the questions, incidentally, but if I was a developer in India or another emerging economy, where would you now tell them to focus their efforts? Is that the same, or do we think that it changes matters?
First, sort of one thing that really grinds me about the question is you don't need to be a developer in an emerging market to target an emerging market, right? So let's face it, the emerging markets are actually going to have a lot more mobile users than the non-emerging markets, so hopefully we're all targeting all of them. And the things that you do for the emerging markets, if it's a situation where bandwidth is severely limited or network connectivity is limited, a lot of the things that we've been talking about here for offline are going to be huge. Like Serviceworker is going to be huge. Reducing the amount of stuff you're shoving down to them is going to be huge, especially on the initial load and stuff like that. But everything you do for them is going to be beneficial for all of your user base anyway.
How does that... So let me put it this way. According to the HTTP archive, I checked 58% of the web has pages that are 1 megabyte or larger. That was as of the start of this month. And certainly we're pushing to
Actually, it's close to 2 megabytes, I think.
Yeah.
Which is scaring the crap out of me.
Yeah, right. And we're kind of pushing to have these richer experiences, which kind of implies more JavaScript, more resources, just more of everything. And even without Serviceworker, if you're talking about, say, somewhere where Serviceworker hasn't shipped that much, should we be looking at, say, lo-fi versions of sites and apps? Where's that dividing line? Do we sort of go, well, actually, I look at this market and maybe it doesn't do so well here, and I want users here, therefore I'm going to scale things back. What do I do for the people who have good connections? Lots of things in there. Who wants to tackle that?
Bad connections, I think, a lot of us sitting in this room, at least if we're developers in the US like I am, sort of don't realize just how bad connectivity really can be, right? So when it takes 10 seconds to sort of get like the first 15K of your page downloaded, right, and 30 seconds to just get the rest of the HTML down, like the other megabyte of image resources just isn't even on the map yet, right? So the only way to address that kind of market is to simplify. And that might mean you should be simplifying your entire app experience, right?
So what can we do then to make that actually a real thing then for developers? If, like you say, it's very easy to forget, and unless a developer is very willing to go and, say, spend time with webpagetest and manually set up all these tests, like how can it be more front of mind?
I think the answer is research, user research. You need to be talking to your users and studying them. And studying their behavior and studying their actions. I know that it's very difficult to classify users on poor connections in many cases. You can sort of understand the total RTT time from your first payload and then understand maybe something about their latency. And I know that that's difficult. We have looked at Google at systems that will allow us to classify users based on those sorts of signals that we get from the network, but those aren't available to everybody yet. So I think there's a tools gap, understanding who your users are, where they're coming from, what sorts of experiences they're having. Real user metrics are an important component, and then doing science about the performance as opposed to guessing. Like talking to users, looking at the actual performance, looking at the actual engagement, and then running tests, A/B tests. You got to test, right? Like introduce artificial latency, see how it affects usage of your site. Come back and see what happens if you reduce the latency. If you do a performance pass, what does it improve? Does it improve engagement? Does it improve responsiveness? You'll figure out where to invest only by looking at the problem with an open mind.
I was gonna add one thing that's pretty concrete here, which is there's a lot of APIs available for identifying what the network story is and collecting it from the wild. navigation timing. You can reconstruct the entire network waterfall for every single page load for every single user, send that back to the server, and then take a look at it in aggregate, see what's happening. Even in Google Analytics, you can get the page timings, the page load timings for absolutely all your users, segment them out. You can get an idea of how long things are taking right now. So that's definitely something to look into.
One thing that I'd love everybody's feedback on here is some peeps at Facebook have been throwing around this idea of device classes and network classes, which is separate from like whether you have Wi-Fi. It's more about, okay, you got good pings, terrible pings, low pings, whatever. And then the same thing, you have a 2010 device, you have a 2011 era device. We obviously don't have this on the web. It strikes me that this is kind of interesting. Please reach out to us if you think that's something we should be pursuing, because it seems interesting. One other comment there, keep in mind that like 640 by 480 is back when you go to the developing world. So you don't need a megabyte of JPEG for 640 by 480. So 480 by 600, I guess, because they make it vertical.
In terms of reducing the bytes transferred over the wire, with the Chrome data compression proxy, we found that a few simple things actually go a long way. So the proxy actually does some very simple transformations. It applies gzip. So in 2014, it is surprising the number of websites and servers that don't use gzip, even though it's just one line in the Apache config file. Transcoding images to WebP, huge gain. CSS minification, stripping white space from JavaScript. I mean, these are small things, but in aggregate, the Chrome data compression proxy achieves about 50% reduction in the bytes transferred. So even those simple things can go a long way in actually reducing the number of bytes that you have to send out to the client.
And I'll point out that, in fact, mod PageSpeed can do that exactly for your website, right? That the Chrome data compression proxy is doing for users what we do for site owners. So if you're not serving WebPs, for example, to Chrome-enabled devices, you should think about serving WebPs to Chrome-enabled devices. And we can do that for you, but there are other techniques out there to do the same thing. And that's a huge savings in bandwidth for devices that support that.
All right, so let's move on. With the shift to HTTP2 and Speedy with SSL, is it better to have multiple smaller files or fewer larger files? Obviously, straight into the technical stuff. And this is from Matt. It doesn't look like a poll to me, but let's ask it anyway.
I think the short answer there is yes. HTTP2 has features like multiplexing, priorities, stream dependencies, all of which work much better when you actually have multiple smaller files. The one caveat that I would add is you have to make sure that so domain sharding was something that people used in the past to get around the IE's limit of 2 connections per host and so on. That is not going to work with HTTP2. With HTTP2, you have to make sure that your hosts should. So domain sharding is not something that you should be doing for HTTP2. Today, if your host resolves to the same IP, then Chrome will sort of transparently unshard this for you. But that's not something that is recommended for HTTP2 going forward.
Is there other things? Are there other kind of, let's say, best practices that we've kind of baked into developers' heads over the past years about how to work with HTTP as it is today that actually now break, for want of a better word, when we hit HTTP2? And how do they migrate from one to the other? And is there a seamless path for them, or is it just
for the most part,
switch?
The transformation should be handled by the server itself. So for things like priorities and push, the servers are typically configured to do that. So the developers don't really have to do a lot of work, but you have to actually go and make sure that the version of the server that you're running, whether it's Nginx or Apache, have actually implemented the features correctly. Because when we did some analysis in the past, we found that some versions of Nginx, for example, got prioritization wrong. I think that's been fixed now, but you have to make sure that the version that you're actually running is something that supports all of these.
And is there going to be some kind of page logic there that kind of goes, hey, if this is HTTP2, just like spit out all the files? Or is it, if it's HTTP1, actually I want you to serve the concat version of all my resources, like old school?
Yeah, so there are some old best practices that are no longer applicable, right? Or necessary, I guess is probably a better way to put it. Spriting is no longer really something that you have to worry about. Concatenating the files together, also not something you really have to worry about. Being able to version the individual resources and change just the one file that changed without having to push down your whole package is one of those huge things. Sharding also, serving content off of a static domain instead of your main domain. All of these things that sort of require another DNS lookup or another socket connect sort of hurt you. So if you can serve as much as possible off of your base domain, you're going to get as much benefit as possible. I think we're at the point, so domain sharding was a big deal when there were only 2 connections per host. It's been a long time since that's been the case. So that's no longer something that you even have to care about. Is it a new browser or an old browser? If someone's still using IE6, okay, they'll have a slightly slower experience because you're not domain sharding. Yeah, they'll get over it. Or hopefully
kind of feels
they'll
like they might have other problems if their browser is that old at this point.
And
right?
we're actually at the point now where all of the modern browsers support Speedy or HTTP2. It's going to be kind of a little period in time where you're going to have to sort of think about supporting both. IE11 is sort of the one edge case where I guess on Windows 7 it doesn't support it, but on Windows 8 it does. But Safari rolled it out with iOS 8, Firefox has had it, Chrome has had it. So you're probably at the point, look at your market share for your user base, but you're probably at the point where you can just shift, right? It degrades gracefully. If someone happens to be on one of the older browsers, they'll get a slightly slower experience, but it saves your life a whole lot of effort, and everyone on the newer browsers gets the really great experience. And, you know, while you're doing all of this, you also sort of bake in yourself to be able to do all of the new cool stuff, like service workers. It needs TLS, and if you want fast TLS experience, you're going to want to use Speedy or HTTP2. So sort of do all of this to get prepared to use all of the cool new stuff.
All right, so let's move on. A question from somebody who's labeled themselves as Time Hat. I'm not quite sure what that is, but anyway. For larger web apps, what have you found to be the best balance between serving like all resources needed up front, like larger initial delay, providing resources needed for a set of functionality on demand, like just holding off, and how does that change with Serviceworker, if at all?
Just really quickly, for the love of God, please don't try to load something the minute or the instant a user is trying to do an action. You can fiddle and get stuff in during idle cycles if you don't want to sort of pay the upfront cost, but you really don't want to get in the way of their activity. So if you're going to delay something, don't delay it until they actually go to use it.
A second order concern here is to beware of radio shutdown on mobile devices, right? That once the radio's been idle for long enough, it's going to take you longer to spin the radio up and start loading the resources than it might have done to load the resources you needed up front while the radio was still running. And it's going to eat more of their battery too, which is going to piss them off.
So since there's no radio API, how should a developer attack that particular problem? Should they just kind of go, you know what, I'm just going to do it all up front and hope for the best? What if it then, we're talking like 1, 2, 3 megs of stuff?
So we actually sort of see these problems show up in large-scale Google apps. So Google Docs and Gmail sort of have this problem, right? They're putting megabytes of JavaScript down the wire to help you get through your day. And in Gmail's case, what you see is that they will load the whole package up front to optimize for interaction latency. And Google Docs takes a different approach, which is interesting because they've sort of constructed their application so that you load the initial content and you get the document, and then they load in editors. Like you load in these packages of things which sort of decorate the UI and make it more interesting. The thing you can do with service workers that will allow you to maybe do better in the future is if you structure your application in that way, where you've loaded an initial experience and then you decorate it later, you can make sure that you've got those things starting to install and starting to be kept at your initial page view when you install your service worker and register it. That activation and installation phase will happen pretty much while you've got the radio warmed up the first time. And then the next time you load the page, the service worker can know that it's got those caches filled, it's in control, you can serve the full experience. So again, it's progressive enhancement at the network layer, and it's going to be available on mobile for Android, beta in a couple weeks, and very soon towards the end of the year. So you can start taking advantage of that now.
Please keep an eye on your Sprite Sheets. We went through this lovely experience recently where a well-meaning app had a 26 megabyte Sprite Sheet for all the icons in 3 different pixel densities, and that was unfortunate.
What's bad about that?
So we've seen people putting their eyes toward SVG, using source set and the picture element, and try to really use this or Scream if you can't, because that combined with HTTP2, we're trying to articulate a more sane way to do this. I don't know that we've the reality of like supporting older browsers is still there, but say what you mean is a really good thing to keep trying to do, because 26 megabytes is rough for us.
Yeah, that's sizable. That's something else, isn't it? That.
Yeah.
Okay.
It was a good day.
Yeah, I bet it was. On the service worker thing, like I get that it's first load, you still have to care, and you still have to kind of do a good first loading experience. And for like second load and beyond, does that just solve all network performance issues now? Are we done? Can we just kind of say, that's it? Now it's solved. Is there anything that Service Worker doesn't actually fix for us on the networking side?
Aside from actually making your breakfast and letting you ride to work on a unicorn.
I'm not trying to dig at you. I'm trying to just make sure, because we've all been like Service Worker, woo! And I'm just trying to make sure, like, is there any gotcha here that's like?
So it's worth noting that there are going to be many users in the next couple of years who don't have Service Worker enabled browsers, and that's going to be it's going to create tension in your design. It's going to create a difference that you're going to have to reckon with. And again, that first load experience matters. And it's also important to note that if you're going to be caching 26 megabyte Sprite Sheets in a Service Worker, I don't know that makes it saner, but you could, you still have to download the 26 megabytes. And if someone is paying per kilobyte for a connection, that's still a pretty crappy thing to do to a person. And in fact, it could be worse than today's experience, because you're not going to see the loading bar necessarily. And these may be bits of the UI that don't reflect stuff that you're currently displaying. So it's going to be worth paying attention to the overall budget. Again, we're going to make the navigation timing and the resource timing APIs available from inside the Service Worker at some point in the near future, which will allow us to let you have a handle on what you're doing and what the network looks like from that perspective. But you are going to have to stitch those experiences together yourself, and it does create tension. It is going to create opportunities, but they're opportunities that we expect that you're going to have to be careful about.
Great. Just on Service Worker, one final one that I think is quite good. Where is the line between relying on the browser's historical caching mechanism, like cache control headers and so forth, and implementing your own caching and just saying, I will deal with this, especially for static or less frequently changing content where you're not quite sure, should I go to the network, should I not?
So the mental model that you can adopt when you're thinking about the caches API inside of a Service Worker is that it's like reference counting, if you're familiar with that. It's the HTTP cache sits logically behind the Service Worker. So it's like document, consult Service Worker, consults cache, consults network, right? So there's now several layers of faulting. When you make a request, you can get it from the Service Worker maybe, and its caches, or you can get it from the local HTTP cache if it's not expired or evicted there, and maybe you can get it from the network if none of those have joy for you. And so what that means is that the Service Worker's primary advantage in terms of caching is knowing what's there, not necessarily anything to do with eviction. Caches are coherent. That is to say, if you evict a cache, it's going to be all gone. And that's their primary virtue. You otherwise don't know the state of the HTTP cache. Service Workers let you hold on to something longer than your cache headers would otherwise allow you to. So the primary benefit is that now you can understand what's there and hold on to it in a way that is more reliable. The browser, when it goes to throw away older resources, won't throw yours away. But if both the HTTP cache would have still had it and your Service Worker is holding on to it, well, it's still going to be there. And when you're populating your Service Worker, all the caching headers that you set for the HTTP cache will take control. So that is to say that if you set so long expires header on some resource that you are then going to hold on to from inside your Service Worker, we don't have to go back to the network to get it when you start populating those caches. And so it's still a useful thing to do to set some distance forward in the future for resources that you're going to put in a Service Worker cache.
Okay. Don't forget, you can ask questions in person. You can also tweet at Chromium Dev, and you can ask your questions, and I will find them. And
really quick, I think along those lines, one of the things that has me most excited about Service Worker is being able to stomp on the cache expires of third-party resources. So I can do things like stale while revalidate entirely in Serviceworker for like the ads.js, where I can say, hey, I'll always serve whatever I have, then go out and fetch whatever the latest version is on the network. If the network's not there, great. It doesn't fail my page at all.
Yeah, one of the other things that we've seen teams here talking about with service workers as they're starting to investigate it is that many of our teams have very large JavaScript payloads, and they'd like to only serve a delta. But if you don't know what's in cache, then you can't figure out which delta to send, and you don't know how to apply it. The service worker would let you do all of that programmatically. You can do it yourself in code because you have all the control. You have the ability to start implementing truly exotic strategies for reducing not just that upfront burden and that second time burden, but the ongoing upgrade costs of your application.
Alex, in a previous panel, mentioned this concept of an app shell, and I think it's really important to take that to heart in then running with your caching decisions, right? This notion that the most important thing for you to do, especially, and this just falls out of building a native app, for example, is to get your app up, get a spinner up if you have to, but get content up, and go to server to get more content, or get your interface up and then show and then provide clicking. And as long as you've got enough of your shell up that you can provide visual feedback that you're getting something. So if you tap down, if you don't have your data back yet, give them some visual bling that says, yo, I'm working. This is a much, much, much better experience for people. And so if you start with that idea of I'm building a shell that then goes to the network, you're gonna end up, I think, in a better place in the total run than if you start bottom up and think I'm still shooting a page across the wire in its entirety.
One note of caution about HTTP caches, though, is that you should never assume that reading from the cache is always faster than going out to the network. We have seen cases where they take about the same time. This is because disk reads from mobile can sometimes be really painfully slow.
And it gets worse on desktop where you've got antivirus software, which is, again, written primarily as a practical joke on users. But disk reads can be very, very bad. I'm not just up here to try to sell you service workers, but you should get some. But service workers will also allow you to race to the network. They'll let you race disk in the network and respond with whichever one comes back first. You have the control to do that yourself. Which is, again, a new thing you couldn't do before, so I'm very excited about it.
I'm pretty sure Jake's Train to Thrill sample does that exact model. So if you're like, how would I do that? There you go.
Yeah, I would. In terms of like building a shell and populating it, I again can't recommend Jake's Train to Thrill code base enough. It sort of has eked out every last ounce of network performance there, getting you out of the gates quickly the first time, and then building the app in a way that lets you be as fast as you can locally, and then load in new content later. It's a beautiful exposition of how to architect your app at the network.
All right, so we're going to switch gears up to the bit after it's loaded. 60 frames a second. This is a question from your lovely, warm-hearted moderator. 60 frames a second seems so hard to get on mobile, often requiring hacks and code contortions. What's being done about this, and can we ever realistically expect 60 frames a second on mobile to be the norm?
Yes.
And what's being done to make that a reality?
He's such a warm-hearted moderator.
I know. Oh.
So Ryan was up yesterday and gave this overview of how we're just seriously focused on being wicked fast, right? We've done a huge amount of work over the last year, both not just looking at 60 FIPS, but just all the little details of that, hundreds and hundreds of bug fixes, 60 or so major projects that have gotten Chrome from that cited number of 129? Yeah, 129. Not quite 128, which would have been pleasing.
Very pleasing.
Very pleasing.
That was it too.
Live in a monk kind of way.
I just love all that.
So we've done that, but we're gonna keep doing that. And so, for example, the GPU rasterization project, we have it on some smaller set of devices now. We're going to try to get that everywhere. And then we're really looking at all the secondary things on the main thread that happen. So, for example, we're looking at how fast, whether GC is hitting at the right time, right? Scheduling. We're looking at how input is delivered and trying to figure out ways to coordinate your scroll with your scroll handler, for instance. What else are we doing, Paul?
Slimming paint.
Slimming paint. Yeah, we're re-architecting the entire Blink rendering engine from the way it was done since it was WebKit to this whole new thing that we think will give us about 2x more performance on Paint.
So
which is pretty cool.
Yeah, it's great.
Or more. 5 sometimes is.
Yeah, it's a lot. It's cool because, well, it's interesting because like a lot of times you'll hear something like Paul Lewis will give a talk and kind of tell you these are the things to follow. And these are your tips. And you should go and write your app like this. And good stuff. Yeah, certainly. And at the same time, like we don't just like let Paul do the work and then say that Chrome's done. Like we are very invested in making sure that we can give you that awesome performance that we're all chasing after without you having to do all those hacks. And so that's why a lot of these projects, like Ganesh, like slimmingpain, a lot of input latency work is all about what are the fundamental platform improvements that we can make to get you there so that you don't have to do things.
So, because one of the things I often stand up and say is like transform and opacity, because these are like the compositor-only things, and everything else will possibly cause you jank problems, probably, And so, do these improvements actually mean that you could transition with height left top without causing a major problem?
So, so right now, transform and opacity, fast across all browsers, every browser. This is just something that all browsers just throw the GPU. When you animate pretty much every other attribute, it requires a lot more work. Things are slower, so that's why animating left and top or animating height, not so great. It's painful. It's not good. A lot of the effects that you see that are coming out is very dependent on things like a height animation. Like you have a height animation, you have things fading out. That should look and work great. And right now, the best you can do is basically just like try and fake it with transforms, and it doesn't really work. And we don't think you should have to go through those sorts of contortions as a developer to get those sorts of effects.
I like asking people how many properties there are in CSS. And actually, it's kind of hard to answer it, which is very telling. But it's something like 115 if you're conservative, or 300 or 400 if you start looking at the real world. It's a lot. 2 are fast. Maybe 3.
Yeah, 2.
There are two directions that this could go. And where this heads is partly a technical problem and partly audience participation with other vendors. One direction is that the browser starts making painting properties. So look at csstriggers.com.
Yeah.
Painting properties like border color. This doesn't affect where things are, it just changes the visual appearance. We can make those really, really fast. But if you look at all the effects you see on mobile, things move around, right? It's nice for things to change colors, but what really makes something compelling is things move, and that's CSS layout, and layout should be fast. The data show, when we really, really dig into it, that we can run layout at 60 FIPS without breaking a sweat. It's just that nobody ever measured carefully and determined that. So where we think we should go in the platform is to actually enable 60 FIPS mutation of any of your CSS properties, because that's the natural way to do it. But that is an opinion held by a lot of Chrome engineers, and we kind of need to hear the audience's voice about whether that's what you want too, or whether you'd like us to. Yeah.
That sounds like a yes. If I was it's hard to discern. I think they need to clap louder. No, it's
but go over to Cupertino.
Just to be super clear, you're saying that you think it's possible to reach 60 frames a second no matter which CSS property you change.
Yes.
I like that.
What was the or?
Yeah, what was part 2 of this one?
Well, so the hard part here is that requires some really hard examination of the fundamentals of web rendering. You have to really start going, we're going to optimize the core of the renderer rather than bolt-on compositing magic on the outside. And so what leads us to the point of being able to say we think we can do this is a year worth of major re-architecture and another year already planned of even more major re-architecture. That's a lot of work. We can do this because Chrome and Google were determined to move the web forward, and so we think we can do this. But this is a tough order for our friends in other vendors. And so the more pragmatic thing here is to say, oh, that's going to be really hard. Let's make background color easy to animate. So it's a tough space. We sort of recognize the tension here. I still think CSS is a friggin' awesome thing, and it's a shame to throw it out when you want to grow something taller, and you have to do so by bypassing it.
So sort of in the interim, while not everything is 60 frames a second, if, say, 30 frames a second looks less janky than something variable, are we saying to developers just kind of still go for 60 and just don't worry about everything less, or are there ways in which we would say, well, actually, you should throttle back? Are we looking at ways that we suggest people throttle, or are we just sort of saying, go for the best you can and we'll try and do the rest?
So the web platform traditionally has had a series of problems. You heard about web components yesterday and Polymer, and that came from some of us asking a question like, why can't I do what the browser does? Why can't I run script to do what it's clearly doing? It's parsing a thing, it's got a tag name, it looks it up in the table, it creates an instance of that thing and spits it back. Why can't I be part of that conversation, right? It's doing that work, why can't I be part of it? Implicit in this question is the reality that today in CSS, you can't be part of it. There's just no way that you could figure out how style recalc is happening or when a frame is generated and control that in any meaningful way. We have request animation frame, which is effectively a bolt-on that tells you when we're going to swap buffers or something like that. And we've got CSS animations, but there's no API that connects them. This is one of the fundamental challenges of the way that we have to design new APIs for the web platform, which is to draw these connections together. And it's something that we, frankly, on the API design side, have traditionally done a very poor job of. Because it's much easier to design a new feature that solves a problem that someone says, hey, I've got this problem. I want to make things animated. OK, we'll design some CSS stuff. Okay. Hey, you can animate something. But I can't animate everything. But I want control. How do I do it? What we didn't do was to say, well, here's an API that gives you control that lets you do all this stuff. We have, I think, collectively made a shift on the back of the Extensible Web Manifesto and some of that other thinking over the last couple of years about how to deliver new features to you. And I think the thing you can continue to demand of us is, why aren't those two things connected? Tell me how we connect those. If I want to do it at 30 frames a second, what is the API that I use to make that happen? Tell me what it is. And today, talking to us, the answer is we haven't given it to you, and that's on us. Our bad.
I feel like I want a bug report for this one.
Yeah, that sounds good.
The web needs something like this. We do have the frame timing API, I guess.
Yes.
Coming,
No.
and that's going to be pretty cool.
Yep.
And we, this gets back to some of that device classes. Like, hey, yo, this is like a really cheap device. Maybe I should show the non-animated UI. So for example, we've been working very closely with in L. So in Lollipop, you'll see a new look to Google search. And that switches between a full material design with lots of animations version and it's still the same look, but there's no animations on lower end devices. And that's a pretty good technique. Right now we do that by user agent sniffing.
See, they sigh, but really they enjoyed that.
But we do this. Yes, I know.
They go, actually, I'm going to do that.
It's this thing. We might want to do better.
Yeah. Going back to the point you made about the extensible web and so on, and explaining the platform, but there's been a rise, there's Famous, there is React. They sort of virtualize the platform and explain things in a different way and then sort of bake out to screen. And they sort of certainly project breakthroughs, right, by achieving 60 frames a second for web apps, mobile apps, and like they've introduced DOM, WebGL, crazy mixed modes. What's the thoughts on this? Like, should we be looking at this kind of thing? Are there any drawbacks that we see when people go in this direction? Like, is that something you guys want to talk about?
I'm looking at Paul, but I can attempt to
give it a shot. Give it a shot.
Famous is leading the way in a lot of regards on this, and there are a couple other frameworks that are just awesome. We want to look at those effects and make sure that everybody can get to them without a framework. And this is somewhat like the story with web components, where we go, okay, you can build a framework, but this is sometimes a symptom of some deeper problem in the platform. If you have to do and adopt an entire framework to move something from the left side of the screen to the right side of the screen, something's wrong. And we should fix that. Now, yeah, I'll stop there.
Okay.
Ranting to the, yeah.
I'm gonna, so I kind of disagree.
Great.
In that.
Yay, conflict, go! Sorry, I was
Right.
not vying for that at all.
Well, basically, I feel as though pulling off fantastic 60 FPS UI is really hard, and there's not a huge amount of people that like know enough to really do it. And so, in many ways, for that experience to scale across all developers, we need frameworks to exist that have that expertise behind it. Right? This is just distribution of expertise and making sure that it's there. So things that like Famous are doing, things that Polymer and Ionic are pursuing, it's all kind of like giving everyone the ability to pull this stuff off. And it's really important, I think, to as a developer to target the sort of experience that you want and chase that down. And maybe you go through a framework, and that's good. On the platform, we want to make sure that effect is absolutely available for everyone. Anyways, the sort of things. So Famous and what they're doing on the UI is very inspiring. The sort of virtual DOM stuff that React has done now, Ember is adopting, is really exciting, and it drives a lot of the conversations that happen on the web platform on how we can make sure that the sorts of things that they're chasing, we just deliver right out of the box.
As always, Dr. Irish is completely right here. So there's the long term, which I'm speaking to, of like we want to bring this to everybody, but the reality is this is darn tough right now. One thing that's really cool, by the way, is this virtual DOM stuff. One of the fundamental things we don't think we can make all that much faster, by which I mean I think we got another 5x in us, but Recalc Style is hard. It's computationally evil. Somebody just did a proof of how bad it is. It's terrible.
How terrible.
He has this selector that is like, Runa did this. He has this selector that's like A, star, A, twiddle, star, star. It's this horrible thing.
That sounds exactly like the CSS I'd write.
It has to recalc the entire world. This is not going to get that much faster. Therefore, keep the number of DOM elements that you have under control. And we've actually been muttering about saying, yeah, you keep to about 1,000 on mobile, not more. And then if you have to have it more than 1,000 due to scrolling, virtualize, defer, so on and so forth. So keep an eye on that. And Famous and React and a bunch of people are, all the virtual lists, they're all doing this. This is super important for performance.
Descendant selectors.
Yes.
It's, I've done presentations where I've been like, guys, don't worry about it. Descendant selectors are fine, they're fast. Turns out.
Is this an admission, my friend?
It is.
Twiddle is worse, though.
Oh. Somewhere around 2008, I was like, they're slow, and then I'm like, they're fast. But turns out they're very fast to evaluate.
Good.
But this is that Recalc Style thing. It adds Descendant Selector in the Recalc Style introduces a lot more cost. And so staying specific with class names, the sort of BEM style class name architecture that people are using these days actually works incredibly well. And so sticking your classes very localized to your component is just a good way to go going forward. And reduces this cost of Recalc Style.
To clarify the Recalc Style bit, does that mean, like during an animation, say I'm transitioning something in an animation, right? Do we not figure out that you're still talking about the same element and the Recalc Style just applies to that same element that it did last frame? Or are you saying that we have to kind of compute the class name every single time and we never remember it between frames? Does that make sense?
Yeah, I think.
Because it seems like, it feels like if it's expensive, we should do it once and cache that.
He's now gone off into outer space.
Sorry, man. I'm just thinking out loud.
CSS is computationally evil, and here's the problem:
right.
is anytime you do anything at the sort of basic level, anytime you mutate a class, anytime you mutate a style, technically we have to go recompute the universe. Like every single element. So we learn big O notation in undergrad, right? Or somebody beats us over the head with it, and we're like, screw this. But the fundamental thing here is that CSS can get as bad as all of the elements in your DOM times all of your selectors, irregardless. And like this whole like, is descendant selector fast? Is the ancestor selector fast? That's actually just a secondary sideshow. The fundamental is CSS is slow. And then we have these magical, horrible, really painful to understand tricks for certain selectors that instead of having to check all of the universe every time you do anything, we check some of the universe. And so direct descendant selectors are really the only ones that we can do faster, or just class. So the BEM style happens to make the computational complexity of this closer to the amount of change you've done.
Now, earlier you said that...
And then I just went off into outer space.
Yeah, I know, but I like it. Well, you can join me in the
We'll
universe.
try to explain this over and over and over, because this is one of the true evils.
But earlier you were saying that you'd be ashamed to throw out CSS, but at the same time CSS is horrible and slow, and we want people to make fast-performing sites and apps.
Yeah, we need to make an effigy of it.
Okay, we need to
I think part of it is just the issue here is that the algorithmic cost for calculating styles it's specified. It is a thing that all browsers agree on, and so like it's not like something that we can just make faster.
CSS, by the way, this is one of the best things about Shutdown, is that it finally lets you encapsulate, right? CSS works in the small. CSS is fine when you've got like 5 elements and a couple of rules. CSS scales, you know, like a Buick off a cliff. It is terrible at scaling.
That's bad, right, for anybody who's like me and doesn't know what a Buick is.
Although, see, the user, if you have one element, it scales like a Buick off the cliff. But if you have 2 elements in your DOM, just 2, and no selectors, we have to check 82 different permutations just for 2. So this is just to give you an idea of the scope of this thing. It's pretty terrible. So then, then you have 3, and it's 82 times 3. And it's bad.
And just to scope all this, we're merely talking about style calculation. And so this is when you see Recalc Style and purple and timeline, which is a fraction of everything that's happening.
Yeah, so we've paid a lot of attention to this particular problem, and it's a small portion of your frames today. You're going to see a lot more time in well-architected apps in Paint today, and so that's why we're focusing in the next year on Paint slimming.
Okay, Jan, did you have something? Okay, I just want to, so move us on. So Chrome has landed a lot of ES6 features lately, but they're often so slow that they're not usable. Can you make them faster? Now, I think yes, okay. But I think the question is really, how do we prioritize our performance workload? And how are we deciding what needs optimizing when, and we make sure that it fits developer needs? I think that's what that's really driving at. We all happy? Yeah? Okay. Who wants to go? Who decides the workload?
So I just want to give a little insight into how new language features get built. One of the things that I have done is to participate in the TC39 process for defining new standards for JavaScript, new features for JavaScript. And so defining a new feature actually for the web platform requires iteration, right? It requires us to turn the crank a couple of times to decide that something that looks like a real use case has a solution, and that we like the solution, and that users like the solution, and that we can make it fast. That's an iterative process. That's a process that requires us to do experiments, see how they go, see how it feels, write transpilers like Traceur that will allow us to use a feature early and then figure out how it goes. One of the things that you can always count on is that if a feature gets a lot of use, we're going to make it fast as we possibly can. That's a thing we do. That is one of the best things that we could possibly do for you. And so we're going to continue to focus on that. If there's a new ES6 feature, the reason that it might be slow is that it's new. Now, would you rather have a new feature that isn't completely optimized all the way through Hydrogen yet? Or would you rather not have the new feature? And if your answer is I would rather not have the new feature, I think you're not with it entirely. Because let's talk about slow and fast. Slow and fast in JavaScript today is slow is 1,000 times faster than fast was when I was writing JavaScript and making libraries, right? Like, we don't have an interpreter in V8. We only JIT. Okay, that's slow? Okay, let's talk about your workload and what you're doing, right? So these are relative questions, and today, you know, we're going to introduce new features. We need to get new features out faster. I agree with that. And those features need to get faster. I agree with that too. But please form your question. Linus Upson said this. Please phrase your question in the form of a benchmark, and we will pay attention to it.
We've got a live question. You go for it, sir.
Oh, sure. So you you talked a lot about Recalc Style, and you mentioned virtual lists and virtual DOMs. There's a lot of frameworks kind of kicking around. There's a lot of kind of performance optimizations that we try to do at the moment around batching expensive layout triggering DOM operations. Most of that is a lot of mental overhead and quite often very hacky. Are there ways that the browser will be able to learn to take care of this stuff in a more performant, more intelligent way? And is that something you're going to work on?
One of the things that I'm really excited about for this coming year is a measure API. Finally, element.measure. And the reason I'm excited about this, and you can measure an element without even attaching it to the DOM by giving it some initial constraints. It's going to be friggin' awesome. The reason that this is really neat is because right now all of this, there are a couple of great libraries out there that are sort of mutate measure mutate, right? That are meant to avoid style thrashing. That's sort of the way to cope with the web as it is today. But it's all a band-aid around the fact that anytime you attach to the DOM, there are these global operations that happen that are proportional to the size of the universe. And so when you want to measure a little thing that's just the size of, a card, and you want to know, how wide is this? How wide does it want to be? Currently, we actually recalculate the size of the universe, and we recalculate all of your elements. And so this is why it's actually slow. Measure will not have this property, so it'll be considerably less the suck. So that's coming, and I think we should be super excited.
So what's the difference between getting a measurement, like saying, give me all the things you know about this, and then setting, width and height? Give me, what's the developer, what do we anticipate a developer is really going to use a measure API for today that they couldn't do otherwise?
Well, actually, so in the site, the Dev Summit site, right, we saw that Paul's talked about, you want to move a card from where it is in your UI, you have a button, and you want it to grow to take over the screen. But you want to take it over the screen, and maybe you want to center it or something, right? So to do this, you have to set up an animation to scale from one to the other. So that means you need to know from and to. And typically the way you do that is you use get computed size, or you do any number of these, right? Get client bounding rect. That's the one that
I love that. Oh yeah. There's my new best friend, BFFs.
Yeah, I mean there is get computed style.width, which is funky, but So there are all these things, right, that people do now, but those trigger world-sized calculations. And so that's really the thing we're trying to fix.
And do they have to?
Yes. Well, I mean, we can fix it, but we're continually trying to make it better. But this gets to, is the platform predictable? So, what makes, one of the nice things about transform and opacity, right, as a developer, I think, is that when you do figure out how to make your effect work with a transform animation, it's going to be pretty fast. Right? So there's this mental model that you can form in your head about, if I do it this way, it will be fast. When you do get computed client bounding rect square thingy.
That's his actual name. It's only aliased across the get bounding client
suffixes
rect.
to go with browser prefixes.
Yeah.
When you do that, it sometimes is fast. And then sometimes it's catastrophically slow. That's fine for getting by, but I don't think that's what we want to hang a web platform from.
I will point out there, as part of a lot of the rendering performance work that's happened recently, a lot of these issues around layout thrashing have gotten better. So if you go and look at those blog posts about layout thrashing and see the demo where it's try this, it's terrible and slow, try this, it's fast, the slow is actually not as bad as it was before. So there's been platform improvements to just make that faster, and we're a lot more knowledgeable now on the Chrome side about when we invalidate something, when we say that the geometry or the pixels on the screen are old, and we have a lot more insight into how we do that and make sure that we don't over-invalidate so that means we can reduce the amount of work that we end up doing.
Question on tooling. PageSpeed Insights and webpagetest are both really useful to help improve loading times. Are there any plans to extend either or both to measure runtime concerns such as idle FPS, scrolling FPS, memory usage, long paint times, and the prevalence of layout thrashing, just as examples? Pat?
Oh, is that all?
Yeah,
Yeah, I mean, so traditionally it's been about figuring out where people's pain points are and trying to expose that as easily as possible. Sort of the raw, easy version of that was just to implement timeline and tracing, so you can get that from both of them. One of the things that's been on my list for probably the last year, I just haven't had time to do yet, is to do a scroll test. After your page loads, go ahead and fling the page and do the same jank kind of stuff that telemetry does. be interesting to get some feedback from people on sort of what their pain points are and what they want measured. I kind of like being able to provide sort of low-level information and not try and round everything up to yeah, you're doing great, or you're not doing so great. It's like, okay, when you get halfway through your page, you start to jank or something like that. So that's why I've sort of leaned on giving timeline and tracing available, because you have like so much data in there already and great presentation in those tools. It's kind of one of those fine lines to walk.
Okay. And I know the PageSpeed Insights team has been looking a lot at mobile usability, and one of the aspects of that is UI responsiveness. So far they've been looking mostly at, can you use the UI at all on a mobile device, right? Because that's a really important question. That's sort of the first order question when you're visiting on mobile. But I think sort of the next big question is, now that you know that the UI is usable, you can like touch the buttons, are things actually responding well?
I'm just going to add a quick thing. The Chrome Developer Tools, you can go in the network panel, see what the network activity, there's a waterfall. But for professionals that are trying to understand the user experience of page loading, pretty much everyone heads over to webpagetest, where they get a lot of information. DevTools were really inspired by this. The sorts of things that you see in film strip and understanding speed index are really give a whole lot of insight into what the critical path is. And so we are looking to do more work around this so that you get insight into what is between the network request of the HTML and users seeing like the page loaded on the screen, and have that information available to you right inside the DevTools. So a lot coming there.
Yeah, I think it's really important to look at stuff like the visual completeness metrics, because it's really easy to get caught up in the numbers that the browser can send back to you and forget what this really means for your users in terms of what they're actually experiencing on the screen. And getting a feel for tying those two together is really important.
Can I ask a question?
No, I ask the questions around here. When you're a moderator, you get to. Yeah, it's fine. Go.
Okay. Speed index is probably one of the best metrics, best generalized metrics for evaluating the user perceived load of a page. And I guess you invented it? Yeah, okay, cool. Woo! Awesome. So you can get it, it's great. You can get it through a page test, and you can get it through Chromium telemetry. There's a lot of things that are kind of adopting speed index as something that's visible. I was just asking about the work to have that available through the browser, and I know it's something you were into. What's the story?
So the current story is I tried to implement it once in Chrome, and then Nat changed the entire rendering architecture and broke it.
As you do. It was a morning's work.
More recently, we've come up with a sort of a RUM version of it that's almost entirely JavaScript-based, that's based on resource timing, that works surprisingly well. It like correlates 90+% with the video version of it. So I want to try and get a little feedback on using that in the field, see how it goes. There's some privacy concerns and some performance concerns with exposing too much low-level stuff from the renderer out to the DOM for the pages to consume. So we have to kind of figure out where that line is going to be.
One thing that I just sorry. But no, this battle for FIPS is hard to balance against monitoring. One thing just to keep in mind when you think about all your page load times, also think about whether you're leaving the thread responsive after or during the page load. Because the first thing people do when they see your page get visually complete is they're going to scroll or they're going to tap. And if you're offloading 2.5 megabytes more of JavaScript and parsing it and executing it, they're not going to have a good time. So you need to start thinking about that too. This is a lot of constraints, but this is sort of the emerging side of the things, is people load and then they tap. And we don't have great experience there on the web.
And test that on actual mobile devices, because the CPUs and memory on mobile is like orders of magnitude slower than your desktop. And like in webpagetest, for example, we have the timeline little flame chart below the waterfall. And on desktop, it was almost never worth even paying attention to because stuff happens so fast. But on mobile sites, we actually end up seeing a lot of cases where you're actually CPU constrained, even with slow network conditions, and where the main thread is like locked during the entire load of your page and for some period after.
I'm totally going to promote the frame timing API at this point, because even for devices that you don't have, if we're able to ship the frame timing API and that is open for your feedback, on the GitHub repo /w3c/frame-timing. Wow, it's like I memorized it. That would allow you to start figuring out this kind of stuff. You see the CPU time in your frames just after your page load and go, you know what, I have a real problem here. This is costing me users. They're leaving straight after I do this horrible thing. So I think that's a good idea that we should have that, but maybe that's just me. Okay, we, I'm afraid, are out of time. So I know, this is fun, wasn't it? Right?